So the question is, what really is going on? Why is this happening? So, in the past few days, I've been interacting with someone. I'd like to give credit, Will Thompson, who has been challenging some of my thinking about autoimmunity. He's been focused on CD8 lymphocytes, and he thinks that's the primary problem. I've been talking more about autoantibodies in COVID as being primarily part of the issue. Now, I'm going to be explaining something here that I think is very, very important. And it's part of the reason why I'm looking at this is because I am trying to predict the future. So I am not just looking at what has happened and trying to make sense of what happened in the past. I'm trying to use the understanding of the science to extrapolate into the future so that we can then think, okay, if this is going to happen, how can we mitigate it? How can we intervene? That's the job that we have to do. And so this discussion, and I have to be careful about it because this is a kind of discussion. This is why I wanted autopsies, because I needed the information about what was going haywire in terms of the immune system. Now, this is where the piece of the puzzle came in when Will, there's something clicked in something that he said, which but it's not at the forefront of your mind. So just to make everybody aware, I do listen to people when they tell me stuff. I reflect on it, and it doesn't always make sense initially, but I always think about it and try and see if I can tie things together. And what he was talking about is CD8 cells. Now, I don't have any images to describe it, but I'm going to try and explain it inside the nucleus. But this would represent a CD8 T cell. Now, by this point, this T cell is now trained to recognize specific epitopes on the virus. Just one. So if you imagine that just on the spike protein, let's say there were 10 epitopes, there will be 10 different types of CD8 cells targeting a different protein on each epitope. And then these cells multiply. And instead of antibodies will bind to the virus and help the immune system to pick it up and prevent it from binding and infecting. But the CD8 cells will then go, instead of targeting the virus, they kill the cell. These guys don't joke. They just see this cell is infected, kill it, destroy it straight away. So that's the difference with the CD8 T cells. And when I thought about an image to try and describe it, I'll use this image here and see if it makes sense to you. But this is the image that came into my head that differentiates the different kinds of immunity. And in this one here, antibodies are like the bullets. So these are the bullets that you fire to try and hit the virus. So if you have more bullets, you can then target the virus. This is the CD8 T cell. These are the Marines. These guys are the killers. These guys will go and take out the whole building. They're not just shooting at the virus, they just take everything down. And so when we think of autoimmunity, this represented the ACE2 autoantibodies that were being shot at cells that had ACE2 on it. But if you train T cells that they must target cells with ACE2 on it, that is a completely different ball game. That's what I mean, is that these guys are the beasts. And this is what potentially represents the storm that I've been talking about.
Last thing, I've said it a million times in different places, but the reason that the mRNA platform is so dangerous and unfixable is that it has no targeting mechanism.
Yeah.
And that means that the mRNA messages will be picked up by whatever cells they encounter. Those cells will produce this foreign protein as they're being instructed to do, and that will cause T cells from your own immune system to attack your own tissues that are now producing a foreign antigen, because what the immune system does is it looks for cells that are yours but producing foreign antigens, and based on the assumption that they are virally infected, it kills them, because that's the best thing you can do with a virally infected cell. So why do you get myocarditis from an mRNA shot? It doesn't have anything to do with spike. Spike may be making the problem worse, but the fact that your heart cells are producing a foreign protein means that your immune system will spot them as virally infected and it will destroy them. And myocarditis is not the problem. Myocarditis is a symptom. Myocarditis means inflammation of the heart. What is that inflammation the result of? Damage to the heart.
The immune response. Said whatever encoding material you put in there, in this little cassette, this little lipid nanoparticle, is going to be seen by your body as foreign. You're going to mass produce that protein, and it's going to mount these things on its cell surface, and that's going to flag your immune cells to come and kill it, because it says, hey, there's something in me that's not supposed to be in me. That's what happens. That's the process. That's what lots of people don't understand yet. It's kind of interesting how a lot of people are having thrombotic issues. Could be accumulation of garbage in their blood vessels, perhaps. I wonder if that has anything to do with amyloid protein production.
So you're talking about the kinds of stuff that certain courageous morticians have revealed about these giant calamari-like clots that are being pulled out of people's circulatory system.
Could be, although I think that's more, I think amyloids. Now, first of all, these are on-target proteins that would be being produced, like these little bits of protein, not off-target. So this is by design what's being manufactured. And there are also these enzymes that we have in us that cut these things at certain places, such that they have amyloidogenic properties. But the clotting pathway itself and the wound healing process, like let's just say that we have transfection of cells lining the blood vessels, and those cells are marked for destruction by the immune system because they're producing foreign protein. The T cells come along, the CTLs, and they kill those cells. Let's say you have a bunch in a row. So you have a local site of destruction and inflammation there now. And the wound healing warriors are going to have to come in now. You can think of it as, when you get a cut, you have wound healing processes that create new tissue, and it generally ends up being a scar because of the types of proteins and stuff that are being deposited there. You'll notice that a scar, for example, is less flexible. This is also why heart scarring with myocarditis is really bad. So if you think about that happening this is just what I'm imagining, on the lining of your blood vessels, which is what I'm imagining is actually happening to people, you're getting buildups of these wound healing factors like collagen and fibrin. And if you have amyloid, you have you have platelets, and you all these normal things that are also out of control, according to many people. Like the clotting pathway itself is messed up. So
inside all of us lurks a serial killer. A killer whose primary function is to kill and then kill again. These are cytotoxic T cells, a specialized member of our white blood cells. They patrol our bodies, identifying and destroying virally infected and cancer cells. And they do so with remarkable precision and efficiency. There are about 5 million T cells in a teaspoon of our blood, engaged in the ferocious and unrelenting battle to keep us healthy.
Second point is mechanism. The idea put forth for how a spike protein in a vaccine might potentially cause autoimmunity is that there's tons of the mRNA that gets into cardiomyocytes, and that causes an immune response. And then the immune cells attack those cardiomyocytes and cause the damage. There's no evidence that happens.
And we'll maybe get into this later, but antibodies aren't the be-all, end-all of immunity. We forget about the most critical part of our immune system is the innate, the immediate, not that adaptive antibody response. So this innate immune system, these T cells, that would keep T cell memory and say, hey, there's that little virus. Remember that from childhood? Oh, yeah, let's just kill off those little cells that are trying to proliferate. And